Hi everyone, my name is Hope and I am on the Marine Tag Team along with my teammates Stephanie, Chris, and Ryan, and our team is focused on improving tags used in research for different marine species. One of the major issues that modern day tags face is their battery life, specifically the pop-up or PSAT tag. These are tags that collect data from an animal and then upon a set command pop off the animal. These tags then, once at the surface of the ocean, attempt to continually transmit data that they logged, even when they're not in range to successfully be able to do so. So our team has been researching different ideas on how to manage the battery life for the tag after it's popped off the animal. Specifically, I've been researching the possibility of connecting to an open source satellite, such as a CubeSat. There are a variety of different CubeSats available that are in use, such as the Warwick University 3 satellite that's used to monitor different land-based wildlife, as well as the Sweet CubeSat that's used to monitor the quality of water in many different places. Unfortunately, what I found in my research was that while there are many open source options for public use, the cost and other resources required to be able to get involved with these projects is just not within our budget for this project. So we decided against the use of CubeSats. I will now pass it on to Stephanie to talk about the other options that she's been researching. Thank you.
Thank you, Hope. While researching some different technologies for our setup design, I ran across an article about an open source developer kit called Horizon. This kit was developed to unlock access to Argos telemetry that uses 6 satellites to locate the data sources anywhere on Earth. This was so exciting to find because it's actually the exact satellites that the existing pop-up tags use, but also because it would be compatible with Arduino. This was actually first of its kind, and the kit was actually on pre-order. So because of this, the physical kit would not arrive until mid-April 2020, and the cost was about $350. A second technology, though, that I found is called RockBlock by Iridium. It's also available. It uses 66 satellites, so that's great. This module is compatible with Arduino as well and only costs $250. But there's a $15 per month use of their satellites. So unfortunately, these two very cool options are out of our team's price range. So we've decided to go along with the simulated signal for our project. And now I'll pass it on to Chris.
Thank you, Stephanie. Ideally, it would have been beneficial for a group to be able to find an open source satellite module able to connect to the Arduino for our group's testing purposes. Unfortunately, as Hope and Stephanie have stated, this is either financially unviable or it would not be able to reach us in time. Alternatively, our group has decided to mimic satellite signal integrity based on either Wi-Fi signal, Bluetooth, or radio waves, depending on the module we are able to find for our Arduino and the difficulty of how to implement the code. The purpose of mimicking this with the Arduino is basically to make sure that if it's implemented in the pop-up tag, it will only send data if the signal strength is able to actually send the signal. Thank you, and to pass it on to Ryan.
Thank you, Chris. I'm Ryan, and as Chris was saying, when our device receives a poor enough signal, we want it to behave in a certain way. We want it to either turn off or go into a power-saving mode in order to increase the effective battery life of our device. Now, this is obviously a clear benefit. The longer the effective battery life, the longer that the actual tag can transmit information and be useful to us. So that means when we decide upon our signal, which will be radio or GPS or Bluetooth, which one we will decide in the coming weeks, it's forthcoming, we want to be able to mimic an environment where we lose signal strength or integrity, which means we have to create a way to test that. And so we've decided on creating a Faraday cage. That Faraday cage will create an environment where we can put it around our device and it to lose signal. And then hopefully that device will then issue a command and then turn off or go into a power saving mode. Now, how exactly we interface with the signal being received or the signal being lost and then issuing the command is our biggest hurdle that we need to overcome. So over the next weeks, we will be buying our products, we will be creating our Faraday cage cheaply and easily from any hardware store, and then we will go on to solve that last hurdle and then go on to actually building and testing it. Thank you.